My name is Dave Goretz. I'm an SC systems engineer for Palo Alto Networks, based here in Chicago, supporting major accounts. So I'm on the pre-sales side, post-sales, kind of helping them keep going with the architecture. Here to talk to you guys about how to build a hybrid architecture, because we didn't want to say hybrid cloud, in AWS. So I'm going to start with the obligatory security matters slide. And this one is the numbers around data breaches, why it matters. The only reason I bring this slide up here is, you guys can all find this information online. It's pretty straightforward. But it matters because this still matters in AWS. It matters if it's in your data center, wherever your compute is, wherever your data is. The data is what's important. The records are what's important. That's what they sell in the black market. That's what they make their money on. So that's why security in AWS matters. And I'm here to talk about how AWS security works with us and vice versa, and give you guys a visual on that, and then also how it works inside if you have a data center as well, and how you can make a kind of a hybrid deployment around it. So common thread and data loss incidents, this is pretty straightforward. Some kind of exploit kit, spear phishing email, infect the user, move across the network, infect the data center, and steal the data. If you have users coming into the network and their compute's in AWS, I actually have just for a record, I do have a customer that's doing this hybrid architecture where they're deploying our firewall inside their data center as well as AWS. And this is part of the driver for them is if your user is on your network but your network's connected to AWS or vice versa, AWS is now part of your network. Or if AWS is the point where your users are coming in and then connecting to your network, AWS is, again, part of your overall architecture and security model. So these are your cloud security challenges: visibility. A lot of the technology, a lot of the constructs are layer 3, layer 4, IP and port based. We'll talk about why, if you're not familiar with our solution, why getting above layer 4 matters and why it's essential. Outdated inconsistent threat prevention technology, meaning you have layer 4 IP and port available to you as a standard networking practice. Your broadband router at home has layer 3 and layer 4 security. But the visibility around the applications, threats, known and unknown, you need to be in layer 7, you need to be at the stack, you need to be threat-focused technology. And then sometimes the processes can be cumbersome, sometimes they cannot be. But we're going to show you and talk to you about how, if you're running our firewall inside your data center or in AWS or vice versa, how it can be a seamless process and how the two can integrate, and how you can make one consistent policy across both. So this is a little visual for you guys. On the bottom there is your AWS Foundation Services, which includes some security features. But again, the key here is on the right. They're looking after the security of the AWS platform. They're giving you some good tools to start a foundation security, but you need to bring that foundation up to layer 7, to the user, to the application, to the threat. And that's where additional features like ours, as well as other vendors bringing other solutions around, bring additional security features to your AWS deployment, just like they would in your traditional environments. So I guess the question is, for sometimes you're like, I'm building this firewall, I'm building this infrastructure at AWS, I got security groups, or I got a WAF. Maybe I need a next-gen firewall. Why? So here's some ideas for you. Sorry, sometimes these lights bug me, so if I turn around a lot, it's just because I don't want to be blinded. Port-based filtering only. I kind of mentioned layer 3 and layer 4. Everybody here, if you don't know, if you do know, just because port 80 is open doesn't mean it needs to be HTTP. Just because port 22 is open doesn't mean it needs to be SSH. And if it is SSH, what threats are going over it? Opening a port is just literally opening a port. It's like opening your front door and letting anybody in without checking, is it your friend or is it the guy that wants to steal your TV? So you get no application visibility at the layer 4 level. You got to go to layer 7, okay? And if you really get down to one really cool feature that when you look at a next generation firewall, what we can do is you can't control file movement. How do the bad guys move across and steal your data? They're moving a file. If they infect your workstation here, to get that data from the server, odds are they got to move a file, usually a piece of malware, from your workstation to a server, or in the case of AWS, from your workstation up to AWS, grab the data, and then exfiltrate the data, whether that be back down the same pipe they got to that server in AWS or the data in AWS, or straight out a rule you open to get to the internet so you could do updates or maybe get to GitHub. or maybe you're going to a special service with a partner. Any way to get that exfil out, but as long as that port's open and you don't know what's traversing over that port, that threat and that data exfiltration of what the bad guys are after is a lot easier. WAFs are really good at protecting your web inbound traffic. Okay? Use a WAF if you need to make sure that people attacking your web server are going to have a lot harder time. That's what WAFs do. That's what they're good at. Next generation firewall is really good at segmenting your network and making sure it's whatever that application is you want, regardless of port. If you want to make sure your database that's running Microsoft SQL and AWS, and your web tier is talking to it, if you want to make sure it's only Microsoft SQL, and that nobody's being able to brute force your SA password or your administrator password, or send an exploit across that path to pop your database server and steal your data, you need to be at layer 7, and you need to be passing that traffic through a next generation firewall. There's just no other way around it. So this is what security groups, layer 4 firewalls, your broadband router, this is what you can filter on today. A source IP, a destination IP, TCP port, in this case 1433. For those of us that know Microsoft SQL, that's Microsoft SQL's default port. You can change the port, but this is what you would do in a layer 4 thing. You're going to put a rule that says allow source IP to talk to that destination IP, and it's going to pass. Here's what we do. We allow you to have the context of making sure that the user in that session, in this case root, could be anything, probably not the right ID, but you get the point. Microsoft SQL DB is the actual protocol, so they're not actually sending somebody to stop the SQL server and start up a web server or a file share or anything like that. It's actually Microsoft SQL. It's actually only talking to SQL Server. And here's the real context around this visual, is if you're on that application server and you want to do damage to that SQL server or steal that data, you have two options. Damage, denial of service vulnerability. If you don't have layer 7 visibility, that CVE will work especially if your SQL server is not patched, okay? And your SQL server is down and your application is down. The second one there is remote execution. That's a vulnerability they could test and use to see if they can get execution on your SQL server, dump your database, and then exfiltrate it out, either the same path back through or another path they'll find. Those are two contexts you need at layer 7. They're not available at the layer 4. So that's inter-data center traffic. Think about outbound from AWS. So my existing customer and other customers I'm talking to that are considering going to AWS, like, well, I just want to let traffic out to do a GitHub because they need to pull something from a repo or multiple repos, or they want to patch their servers and they want to hit Microsoft's update, or just think of a multitude of services you need to go to the internet for. Well, again, layer 4 is really good at allowing your internal application server to talk to some outbound IP address on 443, as we all know here that it could be SSL. No context, no layer 7 visibility here. Now, when I hit the next button, that's probably a bad idea. So there's your first level of context, is we're going to make sure it's SSL. If you really want to allow it, we're going to let that SSL go to North Korea. Probably a bad idea. Especially if the user's root. Why would you ever permit this on your network, whether it's in AWS or otherwise? So having that layer 7 context is there. And also, we can SSL decrypt in the platform. So what you're going to do is you're going to break that SSL open and get further context and make sure it's actually HTTP, because you can put anything over SSL. IMAP is over SSL, POP is over SSL, LDAP is over SSL. Everything is over SSL for network traffic. So once you inspect that, you get further context, and now basically giving you somebody named root or admin or pick your user, downloading an XE in this case from North Korea. It's probably a bad XE. They're probably trying to infiltrate your data center and steal your movie like Sony. So why would you ever let this ever enter your network or leave your network? And take this context and keep extending it outwards, okay? And that's why you need to move your traffic from just a layer 4 at the bottom up to the layer 7. And that's why having a platform that sees layer 7, that controls layer 7, gives you all this context, is important to your security. So now, I'm going to pause and go, questions, comments, more haze. I see my customer laughing at me, smiling. Yes, sir?
Give us a little more information on layer 4, layer 7 kind of stuff. What is it?
What the difference is?
Yeah.
Sure. So layer 4, layer 3, layer 4. So layer 3 is your IP address. So when you're doing routing, you're letting an IP address go. Layer 4 is restricting down to a port. You open in a port, and then you're done. Anything in the payload, any data, anything that you want to send out that port can go. There's no restriction of what can go out that, as long as that source and destination open, as that port is open to the internet. Layer 7 is understanding that it's actually SSL. Looking at the payload and saying, is that really SSL, or is it something that's encrypted that's made to look like SSL to an unaware device? And then the additional context of where is it going, like, is it North Korea? That's geolocation. Is there a URL? So if it's HTTP, what's the URL? That kind of stuff.
So does it take packet inspection to be able to?
It does, yes. So we're going to look at the payload or the packet, or sometimes this is commonly called deep packet inspection. But we'll look at the payload and find that information for you. And we do that natively. Cool. Yes, sir.
Just to make sure I'm crystal clear on this, assuming you had a server and it had Apache running on it, and you had 443 open with Apache, and they send something in that isn't HTTP, isn't Apache going to get upset about it, and it's not going to route it through, right?
It might or might not. Depends on how you malform the HTTP request. So there's certain ways you can get around. I mean, if it's going to be HTTP, yes, but there's also things that don't conform to HTTP that look like HTTP. And generally speaking, inbound, that's where your WAF's really going to help. This is more like an outbound type scenario where you're inbound. Your user, you're on that machine, you're trying to get from your AWS environment or your internal environment out, and you want to make sure it's actually HTTP and where they're going with that HTTP. Not necessarily just something trying to write over 443 outbound. Did that help with your answer, or no? Give me a look of like no.
I guess I would think Apache would have picked it up and either cubed or routed. So you're saying
Yeah, so Apache will pick it up. But what about, for example, when Apache, if you're running an older version of Apache or Apache that's not patched, and you have an exploit against Apache that'll give you shell on an Apache server. Okay? So if you want to focus really on the HTTP traffic, so there's that. A lot of customers ask me a similar question, so I'll answer a slightly different way. Is I have a load balancer, I have an F5 in a traditional environment, or even in AWS. Isn't that going to handle HTTP? Isn't it going to handle that? So that one example right there is a vulnerability coming through that WAF or that load balancer, or even just straight to the web server. The second thing is, if it's a malformed HTTP or someone's trying to send HTTP traffic to it, do you really want it processing that random garbage? So if it's not HTTP, we're in front of it, we'll filter that garbage. So if we don't see it as HTTP, we'll drop it as, if it's something else like RDP that we know about, you'll see RDP drop, right? If it's unknown, we've never previously seen before, we can control that unknown payload just like we can on HTTP. So when we're in front of a web server, if someone's trying to send unknown traffic, potentially a new unknown exploit, or just trying to muck with your web server, we'll be in front of it, dropping that traffic and letting your web server do the actual traffic. Probably a better answer for your question. Cool. Anybody else have their hand up? Marketing slide. All right. So what do we do? So I'm going to go details. I'm going to spend about 1 minute here, and why the triangle is a good concept to understand here and how we deliver this solution. So on the left side here, the next generation firewall, it's the same firewall, whether it's the hardware stuff you buy and put in, in your office, in your data center, at your home. It's the same firewall that you put in AWS, just virtualized. It's tied into our threat intel cloud. So that's the automation we're talking about here, and why this slide is important is, if we find something unknown traversing your AWS infrastructure, or if we find something traversing my home network, and it's an unknown piece of malware never seen before, we're going to find it, we're going to send it to our threat intelligence cloud, we're going to figure out what it is, and we're going to deliver ways to prevent that to every single firewall that our customers have, whether it's AWS, on-prem, data center, my home, within 5 minutes. So the key here, again, is back to that unknown, right? How do you prevent an attack? How do you automate that cycle so that you're almost as fast as the bad guys? Because believe me, they're automating it. They're at scale, they're attacking, they're doing the automation because that's how they're making their money. So you got to automate in return. Finding an attack and then hunting a day, 3 days later, that's only going to tell you one thing, that you were robbed, okay? I mean, I would much rather, to use an analogy I like to use is, I would much rather have a good security system at home or a really big dog or both and prevent somebody from trying to break into my house and steal my TV or endanger my family or so on and so forth than an hour, a day, a week later when we find it, file a police report. I mean, if you get something happening like that, think about it. Are you really excited that you filed a police report? So, you know, when you're looking at prevention and dealing with this type of scenario, preventing an attack, preventing the data theft is what you are supposed to do. You don't want your data on the internet. You don't want it on Pastebin. You don't want to be on the Wall Street Journal. So prevention is where you want to put your effort, and finding afterwards is kind of a, I like to call it find and pray and hope your data didn't leave, because if it does leave, the cat's out of the bag and everything that detected it doesn't matter. So that's the key around the automation. VM series for AWS. So how do we do this in AWS? As I mentioned, our platform is the same whether it's hardware or virtual. So we have a VM series firewall, and then you deploy it in AWS. This will give you all the context we've talked about so far. Application layer, layer 7 visibility, threat control, known CVEs, finding the unknown attacks, finding the unknown payloads that are trying to get into your network. You can segment your applications. Stuff might get in. Your users might be connected back in through a VPN to this, or they might be connected through your data center. If you're segmented up here and your database is behind a firewall in AWS that's aware that only certain user IDs from certain workstations can get in and only can do it over Oracle or Microsoft SQL or MongoDB or Hadoop, pick your database infrastructure, you're much more secure than if you just simply had a layer 4 thing that's saying my subnet for my office, let port 1433 in or 3306 for MySQL into your network, because you're not sure that it's actually a database traffic. You have no user awareness context. And what if they're using an exploit to get shell on that database server so they can dump your database and take your data? Keep pressing the wrong button. So how do we do that? This is just kind of a visual for you guys to kind of see. I don't know, it's a little bit of an eye chart. But in our logs, when we're logging applications, traditionally firewalls or devices, layer 4 devices are going to log, you know, this IP to this IP on this port. And sometimes they assume that that port means it's SSL. And it doesn't. They don't even look at the payload. What we showed this for you guys today is to actually show you these applications here and say this is actually SSH, apt-get. You'll notice there's no ports here. Okay, we're just showing you all the applications, DNS, web browsing, MySQL, bytes, sessions, and then if there's any threats there. But we're showing you the applications, so you're understanding what applications are flowing through your cloud infrastructure, your physical infrastructure, or both. Because once these logs are in your central management system for any firewall you've deployed, whether it's on-prem or in the cloud, this data is the same, the interface is the same, it all appears the same. Questions? Yes, sir.
With your AWS implementation, can you do east-west blocking, like on an NSX?
On a subnet by subnet basis.
Can you repeat the question?
Sure. He asked in our AWS scenario, can we do east-west blocking? And the answer is yes, subnet to subnet. Yeah, if you're in the same subnet, yeah, you have to basically subnet it down to do that because of a limitation, yeah. But if you're going to like web application database tier, totally. And then VPC to VPC, obviously. Any other questions? Another way to slice that same data, we kind of mentioned, I kind of had that nice slide where we're showing something going to North Korea, and well, some people left. You know, here's your visibility on your traffic, right? Here's all your, you know, do I really need my AWS infrastructure talking to Taiwan or Chile or Brazil? It's just not to pick on North Korea because, well. But this is all visibility on you're going to get that's coming into your AWS infrastructure as well as out of your AWS infrastructure. You know, one of the things I talk about to customers a lot is, do you need to be talking to that country ever, regardless of protocol, right? If you're doing business in the United States or doing business in Russia and vice versa, and you don't need to talk to us, the US, or you don't need to talk to Russia or vice versa, why is your traffic even ever allowed to go there? Why take the risk? Because a lot of times that's where your data exfiltration is going to occur. So this is a traditional data center application. applications of data based on, isolated by policy. So you kind of see our icon for our large data center firewall. But this is a very traditional segmentation thing that you have your finance and customer service. Why would your finance ever need to talk to customer service? Or more importantly, why would your customer service maybe not necessarily need to talk to your credit card zone? They may not need that. The application may need that. So this is a segmentation in principle of who needs access to your data and why. Because your data is right here. This is the stuff that they make money off of. And if they can get into your network, take your credit cards that you have today, and then they do it tomorrow, and they actually, if you go into some of the threat things, there's a demo we do sometimes where we show this site called Joker Stash, where they literally are scrolling a credit card feed from a customer, not our customer, but some other company that's literally scrolling every 15 minutes of new credit card numbers. Those 15 minutes of new credit card numbers are worth way more than yesterday's credit card numbers, okay? So if you're segmenting in this way, one, how do they ever get there? And two, if they do happen to get there through a misconfiguration of policy or you need to grant permitted access, you're going to know that they're there and you're going to shut them down. And they're going to move on to another target, right? There's always going to be a target out there. They're always going to want credit card data. They're always going to want health records. They're always going to want more records. But if you can stop them from taking your data, they'll take somebody else's data. So you don't always need to outrun the bear, just outrun your friend being chased by the same bear, and you're pretty safe. So make it harder on them, start segmenting your traffic. Same principle applies in AWS. Okay? So web VPC, database VPC, firewall, and then the VPCs are protected by the segmentation, but all your traffic is also controlled. But whatever this database is, you now know it's a database from the web. That's the right protocol. You're checking for any known attacks across that layer. If you have direct connect in this way maybe for management. So you have all this total control of this traffic at layer 7. Because right now if you do this without the firewall, you're just going to be opening a port. And at that point, why segment your VPC? Just put it in the same subnet. Because if the port's open, it doesn't matter. Now you have no context whatsoever on layer 7. Questions on how we translate a very standard data center segmentation to an AWS segmentation? Yes, sir.
You deploy one firewall, and then you can manage all the VPCs, or do you need one per VPC?
We need one per VPC. You can segment inside a VPC if you want to go that far. If you want to put web 1 and then database inside one VPC, you can do that. Or in this case, you can, depending on your needs, you can segment. But yeah, we are, because it's layer 3. Yes, sir.
How do you handle routing with a VPN configuration?
Question is, how do I handle routing with a VPN configuration? I actually have a customer doing it, so let me ask you a question back first. Are you saying inter VPC, or are you saying like inbound or from on-prem? So the customer has direct connect coming up, and then we're doing a route around into our firewall after the direct connect inside AWS. So another thing you could do is you could put a firewall in your data center and then VPN up to each individual VPC firewall. They're doing IPSec to IPSec between VPCs as well. And then obviously you could do an IPSec tunnel over the internet, as a backway in case you had an issue with your direct connect. That would be another way to do that. So, did that cover your question? Yeah. Okay. Any other questions? Cool. So why does all this stuff matter? I've kind of mentioned the attack. The guys want to steal the bad guys. So this is kind of a visual for you. So I've led up to it. I've talked about it. But this is the attack lifecycle prevention slide that we talked to. Okay. This is their playbook. They do this every single time, and it works when you get hacked or when you get broken into and they steal your data. When it doesn't work is when you break this cycle as close to here as you possibly can. If you're over here, you're going to have a bad day. Here's where you want to break the cycle. So when you're talking about traditional layer 4 technologies, no layer 7 visibility, this is a pretty easy channel to get through because you're not going to have any visibility into any of this down here. So you're not going to know the application, block known threats. So if it's a known threat signature that's going to try and cause an execution against your database server or cause your Apache server to be denial of the service, why wouldn't you drop it? Okay. Just like if you saw a bad guy approaching your house and you could get him at the knees and stop him from walking, you would stop him. Same concept. Same thing with malware here. That delivery of the exploit is to get in there and deliver malware. They need to establish what's called command and control. Okay? They can just send vulnerabilities at you all day long, but if they don't establish a beachhead or command and control, they can't get control of your network, find your data, and then eventually exfil. So this is the next stage you can stop it. Same thing, threat prevention, anti-malware, layer 7 context around, if we know it's malware coming through that file share, or it's malware that's being delivered via, let's say you have an email server up in AWS, for example, probably a bad one, but you get the point. Why not drop it? Wildfire, if we see something we've never seen before, we'll use our threat intelligence cloud I talked to about in the other slide, send it up to that cloud, tell you if we think it's good or bad. If it's bad, we'll deliver you prevention for the within 5 minutes, but you also know that we found something that's unknown, that's previously never seen before, and you need to go take a look immediately. In other words, something you should care about, not necessarily just an alert. Okay? Then any command and control. So once they get a hold of your server or your database server, they got to take that data out. But they got to do that through a command and control channel. Basically a remote session, usually just a remote command shell. We know what that looks like. Okay? And if we can prevent them from using that ever, they never get to this stage. We also, you asked a question earlier about preventing the Apache. And I want to bring this back to that question is, I mentioned something about if we don't know what it is, you have the same control. So if you know what you know, and you don't know what you don't know, if you can at least segment that, you're allowing yourself to control that traffic. If you block the unknowns here too, blocking control channels and steal data is still prevented. So if you know your database should be talking, your web server should be talking to your database on this port, on this application, and blocking all threats, you've blocked the unknown by its inherent nature, right? If you're only allowing what you know through, the unknown never gets through. And by the way, if something unknown tries to get through, you'll see it in your logs, and you'll have another event that says, I need to go look at that because something's wrong. Maybe your developer wrote something the wrong way, or maybe something's on your web server, maybe somebody got into your first tier of infrastructure and is trying to get into your data, which is what they want. You need to go take a look. So it's a way to say, hey, look at this, you might have a problem there. Wrong button. So command control channel. So same kind of thing, right? Let's say they get into your web tier. Right up here, they want to get to that database tier. They got to go from here around this way. If we know what that command and control attempts or that lateral movement of malware looks like, or even if it's unknown, and we're forcing only the known, which would be SQL or whatever, they're blocked here now. And then, again, data steal is still not stolen. So you have 3 chances to stop them from achieving their goal. Why wouldn't you take all 3 chances? And then finally, if they do happen to do this, and they're about to steal your data, you have the total control go in this way. For example, if you look at some of the data breaches in the market, you find out that they literally just FTP'd the database out to their FTP server, whether it be in the United States, whether it be in Russia or China or North Korea or wherever. Why would you ever let FTP out of your environment, especially in a compute environment like this? If you're opening a port on port 80 and you're saying, let port 80 go out because you need to go to GitHub, or 443, you need to go to GitHub. If you're not doing layer 7, if you're only doing layer 4 and opening that port, the bad guy can change his FTP server from the default port of 20 or 21 to 443. It's trivial. So they'll just change their FTP server to every port. So I can tell you for experience, bad guys, when they have the FTP server for data exfil, they put their FTP server on almost every single port, especially 8443, because they know everybody's got a layer 4 firewall that opens port 443 because it's supposed to be SSL. And then they just FTP out on 443. So again, why would you not add context at layer 7 so you know it's not FTP going out, you know it's GitHub, or you know it's Microsoft Update, or you know if you're talking to a business partner through another connection and it's a database replication protocol, not an exfil of data to across that wire. Questions on the lifecycle? I know I kind of went through that pretty quick. Yes, sir?
Well, it sounds more like a production system. There's certain kinds of behavior that we would expect, but we wouldn't expect developers to be doing developer type of behavior on a production system. They would do it on some other systems. So why would you keep them
So why would you keep developers separate from production? Is that another way to word the question?
Yeah, that and the kinds of behaviors and activities that you would expect by those different groups.
It depends on your thing. So like if you're a DevOps shop and you want to roll pretty quick, developers need access to production, and you do. But this way you know what their application looks like. You know that they're using GitHub or whatever their other sources of data are. You know what their code is. And you can distinguish that traffic between traffic you're not expecting. In a more traditional environment where you have a dev, like my customer that's in AWS, they have dev, prod, QA, cert, and a couple other environments. So their developers are in dev, and nothing can touch QA or prod until it's fully deployed in dev, and then it moves, then it moves, then it moves. But that behavior, if that changes, those applications changes in dev, you're going to see it in dev, and you're going to know it's caused by the developers as opposed to potentially an attack. Did that cover your question? Okay. Any other questions? So how do we make this a little easy for you guys? We mentioned at the beginning the policy. Oh, you did?
No, go ahead.
You sure? Okay, thanks. So this is our traditional, your data center here. So you have our virtual firewalls. Panorama is what we call our central management system. How do we streamline that? You can manage all this policy here. It can manage that same virtual firewall. If you create your policy based on users, applications, traffic, let's say your dev environment's here, right? And your prod environment here. Don't know why you may do that, but let's just say you would. The policy that's controlling this traffic can be mimicked here and vice versa. So that way you're centrally managing, you get one pane of glass. You get all the visibility here, so you're knowing what the applications are in your network, whether it's data center based, internet based, east-west inside your data center, or in AWS. Centralized reporting, so you'll see all your applications in one pane of glass. So hybrid cloud topology. Okay, that's a mouthful. So this is very similar to this. One infrastructure for this is IPSec VPN. Somebody asked a question about how would you connect up. This is one way to do it. You can do it over direct connect as well. But basically, you're just building a tunnel so that way all your management, all your control of your traffic is hidden in AWS that way. Your firewall at the perimeter could do that. You can dedicate your own devices. The key here is all these firewalls have the same functionality, so you just build your tunnels in here, and now you have access to that. So you're basically privatizing your compute infrastructure as part of your data center. So this scalable infrastructure becomes part of your data center, and this, in essence, turns it into one infrastructure with the same layers of context and visibility. Questions so far? So, yeah.
Why did you have more than one instance of your VM series?
Here?
Yeah, in this topology.
Scale, potentially. So depending on how many web servers throughput scale, you may need more. Yeah, for scaling. It's a scaling visualization. So in this case, you would scale there with the same policy. Sorry, I should repeat the question. The question was, why did I have multiple virtual firewalls in the visual? Yes, sir.
How do you support an architecture that is auto scale, is an auto scale with one of those connectivity on the web server, for example?
I'm actually going to hit that in about 4 or 5 slides. Sorry, not mean to punt, but I will hit that. Yes, sir.
What do you mean by direct connect there?
So AWS has a service called Direct Connect.
Okay, I'm not familiar.
Okay, it's cool. So AWS has a thing called Direct Connect, which is kind of like a private circuit, MPLS or internet to your data center. Some people treat it as a private connection. Not my recommendation. It's potentially an untrusted network. Not that AWS is anything bad, but when you're bringing stuff into your network, whether it be a feed from a cloud provider or a third party, yeah.
It's not private, it's dedicated.
Marketing versus actuality. Any more questions before I jump into the steps? So, getting the subnets right. Your subnet route tables need to be established in AWS first. You got to build a foundation, just like you would in the real world if you're building a network in your data center or even in your house if you think about it. You got to get your networking and your basic construct of your infrastructure right first. Okay? So make sure you're going to get your subnets right. Design it right so you have your subnets external here and then your internals here, and decide where your virtual firewall is going to go or how you're going to segment your traffic. Okay? Important thing here is look at your routing, and we're going to eliminate some routes. Let me talk to you a little bit what that means. So make sure you're changing your routes here. Check your routes there. Oops, sorry, didn't mean to hit that button. And make sure your internal routes here are active. So the key is, what's the message here? One second. The message is here. Make sure you're not routing around the firewall by enabling AWS. And in 2 slides, I'm going to show you exactly what I mean by that. Did you have a question up there? Or are you just stretching? Just stretching. OK, cool. If you want to, it's really easy to deploy the VM series in AWS. It's in the marketplace. It's just search for Palo Alto Networks, and you will find it. And you can do a consumption-based model and bring the firewall in and play with it. Bring your own license means you get a license from a partner of ours through Palo Alto Networks, and you basically own the virtual firewall, whether you deploy it in AWS, bring it back and deploy it in ESXi or whatever. You kind of own the virtual firewall. Support all those types of instances listed. We can support up to 8 ENIs, so 8 interfaces. First one is dedicated to management. Slight change note here. By default, the first ENI is dedicated to management. We just released our newest version where you can actually shift the ENI for management to the second interface. That's important for ELB type scenarios where if you want to put ELB in front of the firewall, or you want to use the interface to send traffic to, that allows us support. We're only layer 3, so you got to route to us just like you would on a potentially normal network. And then depending on which support you need and how much traffic there, we do support the CPU, so it kind of gives you the ability to play, to deploy, and also scale. So how do you get there? I mentioned the previous slide. Go back to real quick. Back to the visual. So basically I'm talking about, talking about this connection here. So how do you do that? You basically act as a termination IPSec point. You build a tunnel at your firewall at your office, and you build a tunnel on your AWS. Set up your connections and your peers and your shared key, shared secret, and you will build a tunnel. And now you will be tunneled into AWS, and it will look like it's basically an extension of your network as your routing goes through. Yes, sir?
Do you do that on top of the direct connect, or do you do that and have 2 different routes up there?
In this scenario, we're talking about going over the internet, but technically speaking, there's nothing from stopping you from using that direct connect to tunnel into your firewalls into VPC. Yeah. And then you can do VPC to VPC if it's an IPSec as well. So you can slice that any way you want, really. Specific scenarios talking over the internet. Yes, ma'am. So how do I support? The question is, how do you support 2 availability zones? You'd have to create 2 tunnels, because we're in a tunnel. We're each in AZ. Oh, in the visual? If the AZ is in the same VPC, you can be OK. If your AZ is not in the same VPC, we're VPC based. So, and obviously AZs are VPC based. Any questions? Cool. So here's your challenge, right? Kind of mentioned this, now I'm going to walk you through it. These could be intentionally or accidentally bypassed if your routing is not right. So we're going to force all traffic to the firewall by adding a self-referencing security group. So in other words, you're telling AWS, don't let us get bypassed. Okay. Quick, I know how you do it right here. We're forcing the source here and the source here. This is for managing the firewall in our display here. This way you're forcing the traffic. And then you can validate the config. So right now, web to DB connection via the virtual router and firewall succeeds. So we're basically passing through that gateway, which is 20101 is the firewall. If you've built AWS, I think the first 10 IPs, if that's still true, are dedicated to AWS, and you got to assign above 10. So the 101's our firewall, so it works. Attempt to bypass, change your gateway, literally just add a route on your host, and then you can see once we have the route done, that router doesn't exist. That gateway won't route traffic because it's trying to go through ours. And I'll kind of walk through that pretty quick. Any questions? Another way you can do this is you can use ECMP to scale. So if you're starting to scale your data center and you need some more visuals or thoughts around how to do that, here's a good visual for it. So you got this here. You can use ECMP to get to your web server. So if let's say you had a web application that's internal in AWS that you're scaling up and down, whatever reason, you can use ECMP to distribute the load across these tunnels. So these tunnels are still, this is all still IPSec, but ECMP here is going to do equal cost path and distribute your load across your firewalls. So that's one way you can start to scale your networking and your compute inside your tunnels. Just one idea, one way to do it. Questions? Hi, Fred.
You were waiting.
I was waiting for it. Customer.
So coming back, it'll come, so what you're really doing, I actually don't even know how the heck that's working. Because, so I ECMP to the cloud, and then I go to, how am I changing the IP addresses to get to all those different web servers?
How are you changing them?
Well, okay, so I'm trying to reach web 1. Okay, that IP.
Yep.
Okay? And he can only talk through, because the other thing you haven't mentioned is with those two firewalls, last time I checked, there's no VRRP.
Nope.
So there's some magic there to use the two firewalls, which we'll talk about.
Yep. But yeah, we can dive into details. But if you're doing ECMP over the tunnels, that'll keep your tunnel and your session persistent.
Well, get me, but so I guess how do I get to Web 201 if my ECMP takes me to the upper available?
Well, the ECMP, the point of this distribution is so that you don't have to worry about which one you're going to. If you need to go direct, you have to your tunnel back here. So like if you need to get here from here and you get hunted here, what you're asking? I'm sorry, I'm trying to make sure I'm clear.
We're not, there's a cognitive disconnect between these cases. Unless the block on the top there is the load balancer. That's all that's happening.
Or we're routing it for you this way.
Well, if that weird construct at the top that looks like something out of 2001, if that is
This one here?
yeah, if that's some sort of load balancer. So I'm equal cost load balancing to the load balancer is distributing the traffic to the various hosts, then great,
Yep.
everything works. Otherwise,
There's another way to do that too. Yeah. Ringer. Any other questions? So back to your, kind of helps answer some of your question. So like as you said, on scale, on-prem load balancer, same kind of question. So you're on scale, you can load balance down here, and that'll handle your traffic that way. ELB, another option here. In between this, that can handle your distribution to your question. Another option is Citrix NetScaler or Nginx also work. Key is again load balancing to your question. Automation. So there was an automation question on this, so hopefully this answers your question. If not, raise your hand and we'll discuss it a little bit more. So we have some CloudFormation templates out there. They're scripted to deploy our AWS resources. Stretching your question. Okay. You can do a basic install or a fully configured environment. And there's a lot of scenarios to talk to here, obviously more than we potentially have time for. But we can do a two-tiered example, but you can start scaling that across 3 tiers. And the templates basically allow you to deploy the firewall in a manner using what we a feature called bootstrapping. So what will happen in that case, put your config up in S3 bucket. You put a config for our firewall, security policies, and bring your own licenses is one option. Really technically the only option. There's really no good way to do this with the marketplace purchase, so you need your BYOL, it's just a file. If you want the firewall, let's say the firewall in the image in AWS comes with version 7, just for example, and your standard is 704 or 708 or whatever, you can put that update in your bucket and any content. So if you want our newest threats, our newest applications, you can put that in your bucket as well. You basically attach it to Panorama, which is our central management system, so you're automating. You have your firewall here. You need another one up there. And you basically, it's a VM series bootstrap in the bucket. You point it there, and it will build another firewall with this base config. It'll spin up. It'll update. It'll get to base config, your security policies. It'll license up the device, talk back to management, and you'll have a scaled firewall in AWS. Did that answer your scaling question from earlier?
Now, what I'm thinking of is if you're using auto-scaling and one of those web applications died and replaced by another one, different IP address, different source information, how does your firewall follow what's being dropped or what's being rebuilt?
Okay, good question. I'm going to answer that right now. So one way to do that is we can tie into AWS information sources. So that's a way, that's the access to the AWS API, and we can pull tags out of there, and we can build what we call dynamic address groups. What does that mean? So your resource management in this case here is AWS information sources. And your systems are all going to have this information, IP addresses, tags, names, applications, whatever you want. In general speaking, AWS, you have to work within the constructs of AWS, what they provide as far as tag information available. But you basically build this information database. Now what we can do, dynamically speaking, is we build a group, an address group. Most of you guys may be used to a firewall where you put in an IP address, 10.0.1.1, 10.0.1.2, and if 10.0.1.3 pops up, you've got to make a change to the firewall. Well, if we're building a group off of these tags, by pulling that information from AWS, we're going to dynamically, during time, put those IP addresses in for you. We're going to say these 3 tags match these 3 systems, so we're going to put that here in this group. The policy is this dynamic group here, going this route here. So anytime these tags match, whether it's to come or go, so the line here is to show this box being decommed, we'll take that IP address out for you. If you spin another box up, we'll put it in there for you. No change to the firewall policy, no commit. So as you're scaling your web farm up, as long as you just tag it properly, we're pulling that AWS information sources. You bring another web server up, another app server, another database server, another Hadoop node. As long as it's tagged and you're using a dynamic policy based on your group, it will be added to that group. No change to the firewall. Did that answer your question? Any questions on automating your deployment in AWS for scale up and scale down? Just for reference, this technology, as I mentioned, our platform was the same in AWS as it is on our hardware. This works on our physical firewalls, our virtual firewalls, in ESXi, Microsoft, whatever. If you're doing tags, if this is, let's say this is your corporate network, and this is a policy from your web servers going to your SQL server in AWS. Okay, I know, not a wholly realistic, but the point is, if this was coming from your corporate network and you're doing dynamically, you could update your AWS firewalls dynamically as well, using our APIs, so that this group changes dynamically as you spin up resources or spin down resources. This is functionality you could scale, in a small instance, or largely across your enterprises, depending on what your needs are and how much you want to spend on the time. Yes, sir.
What's the performance impact of running introducing the firewall between your web and your DB server? You have to scale your DB servers differently, the firewalls in between. Does that add latency?
The question is, what's the performance impact if there's a firewall between web and, like a web and database tier, for example? Well, any networking device, firewall or otherwise, between devices is always going to add latency. Depends on how much latency. Generally speaking, we're microseconds latency going through the firewall. If you give us one CPU and you have a lot of resources going through it, you might have a performance problem. If you want to make sure it's going through at the right speed and performance, obviously give it 8 CPUs in the max. You'll handle that there.
Does it monitor the performance impact as well as the protocols that are going through it? Or do we
I'm not quite sure I understand the question.
do we see that impact on the firewall itself when traffic's heavy, that it's limiting speed, or is that just CPU usage?
You would see it through CPU usage or session count being really high. So you would see it through data plane, what we call data plane CPU, or session count being really high. And you can monitor that with various tools. I believe we're working on an image right now that'll let you monitor that type of statistics. So you guys can put up an image and it'll monitor some of our statistics. It's designed to do load balancing scale, but you can get other things out of it as well. Any questions? Yes, sir.
Do you horizontally scale? Like, certain times of day I have a heavier workload, so I can horizontally scale my Amazon workload. But other times of the day, do I always need to be running, the C4XL server? Because during my peak, that's what I need.
Sure. There's a little bit of an answer to that question. So kind of yes. Let me back up a slide here. A lot of animation. I'm looking for the right slide here. Let me ask you a question. So in this scenario here, so there's cloud, like I think there's something called CloudWatch where you can monitor traditional server stats. What we're working on to put out here to do that is a plugin that'll monitor your firewall stats. So things that matter to a firewall, sessions, usage of resources policy, things like that. That server will monitor that. And then that will kick into that bootstrap slide here. And then if that to horizontally scale, we'll see that performance on saying, your sessions, let's say you're at 99,000 sessions out of 100,000. You're going to want to kick up another firewall. This is where then that automation of that tool will kick through this process and spin up another firewall. So the answer, short, yes, but we got to monitor our statistics, not the traditional server statistics.
Right. So you can monitor your stats, so you could horizontally scale just like the rest of my environment horizontally.
Yes. And then, depending on where your ELB is and how you're doing that, that's where you would need to be your other consideration. Okay. If you're in front of us today, you would probably want to put a non-ELB load balancer. If it's behind us, ELB should be fine.
Yeah.
Today. So we're working with AWS on that. So another scenario we can talk about is additional deployment. So segmentation, we've talked about that, where you can bring that tier up there and you can go from one VPC or cloud infrastructure to that. Another one is VPN architecture, and we actually do this internally. And right now, when I'm here, I'm connected into our network through something we call Global Protect, which is our VPN infrastructure. We scale our VPN infrastructure using AWS. So we have our firewall in AWS. If I'm in New York or closer to New York or another location, I'm actually going to hit a firewall in AWS, and then from that firewall in AWS, I'm connected back into my infrastructure. And then that allows me to be anywhere in the world, reduce that last mile latency, give me the scalability to handle more users. For example, we had our conference like 2 weeks ago. If we need to scale there, we could spin up more servers in that kind of horizontal questions you asked. This is horizontally for VPN. Is I horizontally scale my firewall for VPN for my users because everybody's going to crunch the West Coast for a conference. Okay? I horizontally scale for a week, and then I spin it down when I'm done with that week because I don't need that many VPN servers, whether it's web or VPN, same difference. You just horizontally scale that way, and then you use either the tunnel from the firewall in AWS right back to our firewall, or if you have a direct connect, you can go that route as well. But this is like another scenario where if you need to deliver service to your users or a remote location in an office, let's say you have a small office open in Europe and there's no infrastructure there, they're buying a broadband connection, and you want to VPN them in, put a firewall up in AWS, have them VPN there, and then VPN back from that stable, always on in AWS back to your office instead of trying to have them go potentially across the pond individually. So there's ways to scale this and build an infrastructure across using AWS stuff because they have data centers. I don't know how many they have these days, but they're pretty much anywhere in the world. If you have people traveling internationally, that's another option for this type of deployment scenario. And again, as you scale horizontally, you can do that with the VPNs. That was one. We do it internally. That's actually, we eat our own dog food. So that's how we scale with what we call Global Protect and our VPN client. Now I think I'm actually done with 5 minutes to go. Open to questions, comments, except Fred. Just messing with you, Fred. Awesome. Thanks, guys. Appreciate your time.